Hello everybody. So we are going to be looking at section 1.1. Our learning goal for today is, by the time you finish, I can identify families of functions. I can describe transformations of parent functions. So what is a parent function? Well, it's the most basic function in a family. For example, if you're looking at this kind of function, y equals 2x plus 3, you should know that that's a linear function. But that's not the parent function. The parent function is just y equals x. So what we're going to be looking at is what kind of effect is there? If we have this function y equals x, what happens if I put a 2 with the x? So I replace the x with 2x. What does that do? Or if I add 3 to the equation, what does that do? That's the type of thing we're going to be looking at. So a transformation of a parent function is going to change the size, shape, position, or orientation. Whereas a translation is only going to shift the graph horizontally or vertically, but it doesn't change its size or shape. So a translation would be like if I came down here and took this parabola and just picked it up and moved it up or down, that's going to be a translation. But if I'm going to change its shape, like by putting a 3 in front of it, that will change its shape a little bit. It'll make it vertically stretched. So that would be just a transformation and not a translation. So those can be a little tricky there, those two terms. So what are our parent functions? The most basic constant function right here is y equals 1. And that's our first family of parent functions. Y equals 1, y equals 2, y equals 3. While we're here, if you have your graphing calculator, you should get that out. If you don't, pause the video and go get it. I'm going to show you how to put this in your calculator. You're going to go to y equals, clear anything out, 1. I just want to graph this on my calculator. Rather than just hitting graph, we're going to hit zoom 6. So it was zoom right there, and then the number 6. Let me show you again why I did that. Zoom takes me to this screen, and I want a standard screen. You're going to hear me say over and over, zoom 6, zoom 6. So just get used to it. Zoom 6 gives me the standard screen. And there's what the function looks like. The domain of the function is all real numbers for this function. I can use any value for x. If x equals -2, y is 1. If x equals -1, y is 1. Look at the table. You see table right here? If I hit second graph to get to table, see how no matter what x is, y is always 1? Okay, so practice that. Second graph to get to your table, no matter what x is, y is always 1. So our domain again, it can be anything. All real numbers, so we can write that as -infinity to infinity. And the range of this, the range means the y values we can use. The only y value we use here is 1. So this is written in just our general set notation. Interval notation, it would be just 1 to 1. We start with the y value of 1, we end with a y value of 1. Let's go to our next parent function, a linear function. Let's go to that, y equals x. X is right here, next to the alpha key. Push it in. Go ahead and just do your zoom 6. Just get in the habit of doing that zoom 6. Here's what that looks like. You got it here too. That's the most basic linear function. The domain again, I can look at the table. Look at the table. And no matter how I scroll, I can see I can use anything for x. So the domain there is all real numbers. We can write that as -infinity to infinity. The range here, well, the range also, I can get anything. So the range is going to be all real numbers. That's written as -infinity to infinity. So this is the range in our normal set notation and or just standard notation, and this is an interval notation. Absolute value function. Let me show you how to put that in your calculator. So for this one, it's a little weird. You're going to have to go to math, and then you're going to see fraction. And you don't want fraction. You want to go over here to num and get to ABS. ABS is absolute value. I'm going to push enter, and then I get my absolute value bars, x. And again, zoom 6 to graph it. And we need to know that shape. That shape's just going to be this V shape. So we get this V shape anytime we have an absolute value function. The domain, again, we can use anything for x. It's all real numbers, negative infinity to infinity. The range, though, the lowest value that I can use here is 0. So y values are greater than or equal to 0. In interval notation, this would be bracket 0 to infinity. We have to be equal to 0, so that's why I use the bracket. Will never be equal to infinity, so I have to use a parenthesis to say we're just getting infinitely close to it. Okay, quadratic, we have it here. If you want to put in your calculator, you go to x, and then here's the x squared key, so x squared, and then zoom 6. There's our quadratic function. If you want to take a look at the table, you can, and you can see that we're using anything for x. That's why our domain's all real numbers. The range, though, is the same as it was for absolute value. It was just y has to be greater than or equal to 0. Interval notation, 0 to infinity. Okay, so for our first example here, it says to graph f of x, which just means y, f of x equals negative x squared on your calculator. Write the domain and range in inequality form and an interval notation. All right, so we're going to go in here, y equals. Now, very important, I'm putting in negative. Look down here. This is the negative key. You cannot put in subtraction. It won't work. It's going to give you an error. It's negative. Push the negative key, and then x squared. And then do your zoom 6. Here's the way that looks. It's a reflection over the x-axis. So we're going to graph it. Just a quick sketch. Looks like that. We're going to write the domain first in inequality form. Well, it's not an inequality in this case. It's just going to be all real numbers. Here's the abbreviation you can use for that, just an R with an extra little line by it. That's going to be in our regular form. I guess for inequality form, we could also say, can't really write that as an inequality. So interval notation for that domain, you would just go negative infinity to infinity. Another fancy way of writing this, which you might see at the college levels, like x, such that x is an element of the real numbers. It looks real crazy, but we're not going to get into that. We're just going to put all real numbers there. For the range, we can see that all of our y values have to be less than or equal to 0. Interval notation, I have to start with my lowest number first. The lowest number is negative infinity for the y values. And then we go up, 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 all the way up to 0 and stop. Okay, so there's our domain and range. All right, graph f of x equals absolute value of x. I already did this. Let's change that. Let's make it a negative. What do you think is going to happen if I put a negative in front of there? So let's do negative, and then remember how to put this in? Math, num, absolute value, x. What do you think is going to happen? Yep, I'm going to flip it over the x-axis. There it is. All right. And guys, when you're taking these video notes, you should always take a minute and pause and see if you can remember how to do things. You have to be an active learner. You can't just watch somebody. You got to be thinking at the same time. The domain here is all real numbers. Negative infinity to infinity would be our interval notation. This is just our inequality form. The range would be that y has to be less than or equal to 0. In interval notation, we're all the way down here to negative infinity and up here to 0. And that's our answer. All right, let's finish this up now. So now we're going to identify the family function family to which the function belongs, and then describe the transformations. So we have f of x equals 5 absolute value of x. Here it is. So what's the basic family it belongs to? Well, the family is going to be just y equals the absolute value of x. The transformation, though, see, normally that absolute value of x, let's go back to that. I go to math, num, absolute value of x. Let's compare that to 5 math, num, absolute value of x. Compare those two. So there's our normal absolute value of x, and here's the 5 absolute value of x. So what that does is, that's called a vertical stretch. This is a vertical stretch by a factor of 5. See how it's so much steeper? If I look at my table of values, see how normally here I've got a y value of 4, but now it's 20. It's 5 times as much. I used to have a y value of 3 in my original function, now it's 15. So see how those y's all got multiplied by 5? That's a vertical stretch by a factor of 5. All right, parent function here. We've got y equals the quantity x minus 1 squared plus 4. Our family would just be y equals x squared. Now let's look at the shift. Okay, let me put this on the calculator. So normally we're just looking at x squared. Now I'm looking at parentheses x minus 1 squared plus 4. So here's how it normally looks, and here's our new one. So look at this vertex. The parabola, the red parabola looks the same, but see how that vertex used to be at 0, 0, and now it's over 1 and up 4? So that's going to be a shift. We're going to go to the right 1 and up 4. Look at that pattern. See how it went to the right 1. These are going by 2's here. So to the right 1 and up 4. That would be our transformation. All right. Graph the function and its parent function, then describe the transformation. Use a graphing calculator. All right, I bet you already know this, the way this would look. This is a linear function. It's got a y-intercept of -3, which is right here. Each of these boxes represents 2, so I have to go up 2 over 1. I'm going to have to go up 2 over 1. I'm just going to use this as a straight edge, just whatever I got handy. I just kind of like to do this neat. You don't have to be as neat as I am. Okay, so there's the first one. And then I also want to graph the original function, which was y equals x. Now y equals x just means that I have the point 0, 0, 1, 1, just like that. So that's going to come up here right like this. I should use a different color, shouldn't I? Okay, oops, yep, that's pretty good. Okay, so there's the original one. So the parent function was y equals x. That would be the parent function, the most basic one. And let's see what happened. Well, I can see that this got shifted down 3. So that's one thing that happened, down 3. Now the next thing is kind of weird. What happened was that slope changed. So I have a slope of 2. But that slope of 2 can also be thought as a horizontal shrink by a factor of 1/2. Okay, that's weird. Let me show you again on the graphing calculator. Just going to put in my parent function. So here's the original, and here comes the new one. Opposite of the colors I used before, cover that up. Okay, I'm going to go to my table, and can you see how, like, right, let me find a good example here. So here I have, it's kind of hard to tell from the table, but let's look at the actual function. See how this graph right here, if I were to shrink it horizontally by a factor of 1/2, it would actually it would go this way more. And that's what this one does. And then it got shifted down 3. This is something that we'll be talking a lot more about but that's what the result was there. All right, on this one, our parent function would be y equals the absolute value of x. That looks like this. There's the parent. Okay, now the new one. What do you think this plus 1 is going to do? If this one took it down 3, what do you think this plus 1 is going to do? Yep, you're right, up 1. So now we're going to have this vertex up 1 unit. This is almost the same as the slope. It's going to go up 1 over 2. Remember, these are each 2. Up 1 over 2. And it's going to look like this. Up 1 over 2. Up 1 over 2. All right, so there we go. Let's look at it on the calculator. I'm going to do it the other way now so the red matches mine. Okay, so the red one I had, that was our parent function. That was math num absolute value of x. And my other one, the one I was given, is 1/2 math num absolute value of x. Get out of there, plus 1. The plus 1's on the outside. And we'll just go ahead and do a zoom 6. We don't have to keep doing that over and over. I could really just hit graph at this point. So there it is. Can you see how this one now, when this is on the outside of here, okay, this is on the outside of this x, this is going to be called a vertical shrink of 1/2. So we went up 1 and we had a vertical shrink of 1/2. Okay, see how before we'd go up 1 over 1? Now we're only going up 1 over 2, up 1 over 2, so we can think of that as a vertical shrink of 1/2. These are going to be confusing at first, and I promise the more that we go on with this, the more sense it's going to make. But basically, when it's on the outside of whatever the function is, it's going to be vertical. It's going to affect it vertically. This one, you could actually think of two ways. You could say it's a horizontal shrink by a factor of 1/2. You could also say it's a vertical stretch of 2. Because for this one, I can think of it as either on the inside of the parentheses or on the outside, and it would mean the same thing. Okay. All right, let's keep going. Identify the function family and describe the domain and range for each of the following. Write as inequalities in interval notation. Check the graphing calculator. All right, so I'm just doing a quick sketch of this. This is my parabola family, so I know it's going to be that U shape. I'm going to go up 1 unit. I know that's going to be up 1. And normally the parabola is, kind of wide like this, but now it's going to have a vertical stretch of 3. So instead of it kind of like going up 1 over 1 at first, it's going to go up 3 and over 1 at first. So it's going to look like that because it's going to have that vertical stretch of 3. Okay, so identify the function family. The function family is going to be y equals x squared. Describe the domain and range. So the domain is going to be all real numbers, inequality. Interval notation, it would be -infinity to infinity. That means everything. And then the third thing is to find the range. And the range is going to be what's our lowest value for y. So it's going to be y is greater than or equal to 1 as an inequality, or it can be 1 to infinity also. And just checking that real quick. Just looking at 3x squared plus 1. I'll just hit graph now because we've done that zoom 6. It's on the right screen. And I can see that we look pretty good there. All right, last one for this. What do you think this is going to do? Maybe you don't know. Well, first let's identify the family. So the family of this is absolute value. It's y equals absolute value of x. That's going to be our V shape. So what this is going to do, it's going to shift it to the right one. Let me show you. -2, and I go to my math, num, absolute value, x minus 1 plus 3. Okay, so see how it's shifted to the right one? Normally that vertex is at 0, 0, but now it's to the right one. Okay, so describe the remaining range. Okay, so it didn't ask us for the transformation, but it's going to be to the right one, and it's also going to be up 3. So to the right one, up 3. And then I'm going to have this vertical stretch here of -2. So I'm going to have to be going down 2. Let's see, this would be 2. So 2, 4. Ooh, it's a tricky one. Whoops. And then over 1. And for this first section, you're allowed to use your graphing calculator because all these rules are going to be really spelled out for you next time. Okay, so we've got that. Looks pretty good. Their screen's a little different than mine, but like I could check my point. Remember how I said I was going to go down 2 and over 1? So if I'm here at this 1, 3, and I'm going to go down 2, it would go to 1. And if I'm going to go to the right one, it would go to 2. So I should be able to find that point 2, 1 on my table if we did this right. And there we go, 2, 1. So see how I know that my graph is right since those points I can see, 1, 3, 2, 1. Okay? All right, so that's it. So this first section is an introduction. You can use your graphing calculator for everything. Let me just finish the domain here. The domain on this would be all real numbers, -infinity to infinity. And the range on this is going to be inequality. It would be y is less than or equal to 3. And I could also write that as -infinity to 3. Okay? And that's it. So you guys want to do that big ideas assignment, section 1.1.